Hi there, AP Stats students. Let's go through some of the problems I assigned to you from Chapter 20, starting with number 7. Yes, the Type 1 and Type 2 errors are confusing. Again, it's another one of those situations where I wish they had come up with a better term, an easier way to remember this. Again, Type 1 error is when you reject the null hypothesis when you really shouldn't have. A type 2 error is when you fail to reject the null hypothesis and you really should have. Okay. Again, type 1 is Shawshank Redemption. Um, the presumption, the null hypothesis with jury trials is that the person is innocent. So if they provide enough evidence to convince you that null hypothesis is false, we reject that and say that they're guilty. If they are actually innocent, like Shawshank Redemption, Andy didn't kill his wife or that other person, but he was found guilty. That's a type 1 error. You should not have rejected the null hypothesis, but you do it anyway. And that's what's happening there here in Part A. We're hoping that the enrollment in the website is above 30%. We run a test, it rejects the null hypothesis, and later they find out that they should not have rejected that null hypothesis. That's a type 1 error. Okay. Part B. Student tests 100 students to determine whether students on her campus prefer Coke or Pepsi and finds no evidence that the preference for Coke is not zero point 0.5. Later, a marketing company tests all students on campus and finds, again, no difference. There's no evidence. In this case, for Part B, that's not a Type 1 or a Type 2, that the person, the student who did the initial one here, came to the same conclusion as the marketing company did, so that student did not make an error. Part C, pharmaceutical company tests whether the drug lifts the headache relief rate from 25% achieved by the placebo. Because the p-value was so big, the test fails to reject the null hypothesis. Further testing shows that the drug actually relieves headaches about 38% of the people. So they rejected the null hypothesis, failed to reject the null hypothesis, is what it says there. They failed to reject the null hypothesis when you got that wrong. You really should have rejected the null hypothesis. That's a type 2. Now again, examples here, a type 1, you'll see this hundreds of places where you can, again, if we're just trying to stick to books or movies or musicals, the innocent man who's wrongfully convicted, a type 1 error. Oh, you could probably come up with a unique list of 10 on your own. Type 2, man, that's hard to see very many movies like that. Again, the human condition is, all right, if we find out in the end that somebody's put on trial for murder and they were guilty and they're not found guilty, if they actually get away with a crime, oh, people don't like to hear those stories. People don't like to see movies like that. So it's hard to come up with two really good examples. The type 1 error is when you reject the null hypothesis when you really shouldn't have. The type 2 error is when you fail to reject the null hypothesis when you really should have. Okay. I hope that helps. It is a tricky concept. For number 11, a medical researcher tested a new treatment for poison ivy against traditional ointments. He concluded the new treatment is more effective. What the p-value of 0.047 means in this context. Again, for those of you going through with the AP exam, You have to show evidence of your understanding of the concepts here. So what does a p-value of 0.047 mean? Now again, we're saying here the new treatment is more effective. I'm presuming that they used a significance level there of 0.05. This is less than 0.05. That's why they're reaching that conclusion. The new treatment is more effective. But what does that number itself really mean? If we were to go ahead and run more trials, do more experiments, I guess, in this case, from the same population with a sample size the same as the original study, if the effectiveness of this new one isn't any better than the old one, the chance of observing an effectiveness this large or even larger is going to happen by sampling variability alone. Only about, now notice how they've changed the probability of from 0.047 into a percentage. That's fine. Somehow people understand percentages better. Sampling variability, this is going to happen only about 4.7% of the time if you take sample after sample after sample. Okay? Sampling variability is going to explain, is going to produce something as large or larger less than 5% of the time. Okay, so again, in context. Then we're going to take a look at number 20. In June 2010, poll of 800 randomly selected working men found that 9% had taken on a second job to help pay the bills. Estimate the true percentage of men that are taking on second jobs by constructing a 95% confidence interval. We've done these before. Before you do anything else, check the conditions. And on the test, write this or type it out. Yeah, okay, it's randomized. 800 men represent less than 10% of all men. Okay. The success failure condition, write this out, do the calculation, show what it is. 800 times 9% is 72. 800 times, again, the complementary 0.91, 728. Both of those are greater than 10. Sample is large enough. All the conditions are met. We can do a 1 proportion z interval to estimate this. So again, they wrote out the formula, then they show plugging the numbers into the formula. So again, we're looking for a 95% confidence interval. So that's how we get the z star value here of 1.96. They said z interval, so again, that's a predictable thing here. Don't need a calculator for that. So take the p hat, again, from the survey, 0.09. Here's our magic z star number. Again, 0.9 times its complementary divided by n of 800. Crunch those numbers, we'll get something between 7 and 11%. We are 95% confident that other samples, other surveys of all men having taken a second job to pay the bills is going to fall somewhere between 7 and 11%. Part B, a pundit on TV News claimed that only 6% of working men had a second job. Tell that person to stop talking. Again, our confidence interval here said we're 95% confident we take more surveys. This actual population proportion is going to be somewhere between 7 and 11. You've chosen that's something that's outside this range. Just be quiet. 34 then was there. And again, back to type 1 and type 2 errors. Highway safety engineers have some new road sign designs, hoping that increased reflectivity will make them more visible and people will stop driving through the stop signs. Get some volunteers, go through a test course where we have several of the old signs, several of the new signs, and is there a difference? So first of all, is this a one-tailed or two-tailed test? And then that pesky why. So again, I would say here, be neutral about this. Our null hypothesis would be the new signs are just as effective as the old signs. There's no difference in the new signs being more visible. The alternative hypothesis, hopefully, I mean, we've done all this work here. The alternative is that the new signs do provide greater visibility. Okay, so again, the way they phrased it here, the new signs provide the same visibility. The alternative, the new signs provide greater visibility. Now, again, if you just focus in on those, this is only a one-tailed test. All right, we're not saying it's equal to in the null hypothesis and is not equal to in the alternative would give us a two-tailed test. Here, we're saying greater than, this is one-tailed. Okay? What would a type 1 error be? Again, type 1, we reject the null hypothesis when we really shouldn't. So again, our null hypothesis, the new signs are have the same visibility as the old ones, but we reject that in error. So that means the new signs aren't any better, but we think they are. Okay, but they're right. Type 1 error happens when the engineers decide the new signs are more visible when they aren't. Okay. In this context, a type 2 error would be that we fail to reject the null hypothesis when we really should have. A type 2 error in this context is we're disappointed that the new signs aren't any better, when in reality they are. Type 2 error happens when engineers decide the new signs are not more visible when they actually are more visible. If this D, the power of the test. Now again, this is a strange concept here. It refers to our ability to make that right call at the very end. Okay? The power of test is the probability, in this context anyway, that the engineers detect a sign that is truly more visible. The power is again, a way of saying we're not going to make a type 1 or type 2 error. That if they are more visible, we're going to be able to tell that, yes, in the end, our statistics show that they are more visible. That's the power of it, that we draw an accurate conclusion. Don't make a type 1 or type 2 error. There are several things that affect the power of the test. If the hypothesis is tested at a 1% level of significance instead of a 5%, how will this affect the power of the test? Well, in this case, the power decreases. If that level of significance goes down, the power goes down because the null hypothesis then is harder to reject. We need a p-score that's less than 0.01 if we're going to say we reject the null hypothesis and these new signs are actually better. Okay, so if it's harder to avoid, again, the type 1 error is more frequent, is my understanding. If it's harder to avoid that type 1 error, that power decreases. Engineers based on their decisions on the reaction of 50 drivers, but hold on, we got budget cuts. We only had the time and the money available there to pay 20 people to go through the course. So if our sample size dropped from 50 down to 20, the power dropped also. Okay? because we have a smaller sample size, as a matter of fact, less than half of what we planned, that sample size could have more wider variability. P-score is going to go up. Um, we're in danger of making that type 1 error again. That lowers our ability of the engineers here to make the right decision to avoid one of those falsehoods. Okay. So if you want higher power, you use a bigger sample size. If you want higher power, you use a bigger level of significance. Okay. Hopefully that clears up a few of the issues there. Again, take a look at this, rewind it as much as you want, and good luck on that quiz.